Hello everybody, this is Steven coming to you once again through the power of the internet. And for this video, which is being recorded directly after me finishing recording the previous video, haven't even had a chance to render it or anything yet, but I remembered right at the very end that I had in fact done the layout for the board that we discussed. I was just getting projects confused in my head at the very beginning for another one that I had just started, which we will be talking about in another video. But focusing on this one right now. So this is, again, the, quote, dark sensor, if you want to call it that. So we're looking to detect on or activate a relay only when the ambient light is below some user's settable threshold. So this is what the board ended up looking like. We'll see what it actually looks like in MeetSpace once it shows up in a couple weeks from OSH Park. Shout out to them, of course, as usual. Fantastic guys working there. Always excellent service and product and blah, 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 blah. Anyways, also just before we get started, the front and back layer are filled with ground plane, but I'm just going to turn them off just for ease of seeing it. So over on the left-hand side here, we've got our main power connector. So I've got little labels also for positive and ground, just so that then the user knows obviously which one is which when you go and plug it in. Right here, we've got a switch. This is just this was a switch I kind of thought would maybe be the best one that I saw on DigiKey. It's a rocker switch, so it does technically have another position that you could use, right? Because it's a single pole double throw switch, right? So this connector gets attached to either this or this. So I'm just leaving that one unconnected, disconnected, whatever. So usually with these rocker switches, if you rock it forwards, the little internal mechanism will then connect it to that one. So I've got the on indicator is going to be you push it forwards, and then it connects to this one right here on the left. And then while off will be in the opposite direction, which will connect to that. Now, that was just my assumption. I kind of just winged it for the first one. We'll see what happens if that is actually the case or not. Nice big traces here. We're talking, how big are these? Apparently it doesn't want to tell me. I think I made them like 100 mils or something like that. So pretty big power traces going on here. I was aiming for somewhere in the neighborhood of like 3 amps current flow, and this is only a 2-layer board, so you should, according to some little calculators that I used online, somewhere in the neighborhood of like, I don't know, 60, 70 mils should be sufficient, but I just made these ones as big as possible. That way then you can step up the current even more if you need to, without resulting in too much of a temperature rise or voltage drop across our traces. So here's the jumpers that I talked about that connect the main power to all of our circuitry, right? All of the actual analog circuitry that's doing the light detecting. So if you don't want to use a secondary power connector, then you can just go ahead and attach these jumpers and then ignore this one over here. This is going to be the user's adjustable threshold for the light level, so it's just going to be a potentiometer. I'm not sure if we're going to need a linear or logarithmic potentiometer. It's going to depend on our experiments, seeing if people are more interested in more sensitivity down in the lower ranges or whatnot. But we'll see we'll see when we get it made up. Again, that can easily be switched out during testing. So then here we've got all of the KiCad's a little laggy sometimes. Here we've got all of the transistors and other components and whatnot that make up all of the constant current all the constant current sources, as well as the comparator right here, which is the U1, the TLC 3702, and all of these other 3-pad packages. That's the transistors and whatnot, and the other parts that you saw before. For the constant current source, or for setting how much current you want to draw, I have it set to some little surface mount trimmer pots. So those will just be stuck on. You're not looking to adjust those on any sort of regular basis. So they'll probably be just set to 20 milliamps or something like that. And then you can connect your stuff outwards and go. So all these connectors. So let me see if I can get this. Scroll down to a nice position for you guys. There we go. So most of these connectors are going to be screw terminals, right? So P1, P3, P4, P5, and P2 will all be screw terminals with P1 and P2, obviously 0.1 inch pin pitch screw terminal. So identical pitch to your breadboard, as well as like header pins and whatnot that you use for most things, because again, these are going to be low current, or relatively low current, I should say. So we don't need the big connectors. While these ones are going to be the more traditional, larger, screw terminals, right? And I've also included a couple little mounting holes here. It's not designed in mind for any sort of particular enclosure, because you do need to have the light dependent resistor obviously exposed to the environment. So there are ways you could do that, right? You can make this a board with the LDR on the opposite side to all these parts, and make the board like the case or the lid for an enclosure, right? If you look at my USB isolator project videos, you'll see that sort of design philosophy, right? Where you've got just the connectors and whatnot on the one exposed side, and all of the actual components, all your passives, all of your ICs and whatnot on the other side, located within your actual enclosure. Another example of that would be the microcurrent by Mr. Dave Jones of the EV blog, right? He does the same sort of thing. He's got all the connectors, user interface stuff on one side of the PCB, the opposite side, all of the components that you don't want to be touching, all of the passives and the op amps and whatnot on the opposite side, which then get located within the housing. But I did not do that for this one. I just made it all exposed just for the first version. And the mounting holes are just so that if you want, you can put some screws in there or whatnot, some little standoffs, just so that it's not just resting flat on a table. At least then you can have like a little bit of lift off there. But overall, that's pretty much it for this design. Here's the relay right in there. That's just some, couple of amp relay, nothing major going on. We've got also if you just see here, just because of how KiCad works, I always get issues when I'm trying to place vias without having an actual trace associated with it, even if this entire area is flooded, right? So if I turn on the view, right, as you can see, both sides of the board right here is all flooded with copper with ground plane, right, on both sides. So this is just a couple of vias just to stitch the two together, because I was looking, and without them there, ground would have quite the distance to travel, and it was kind of, so if we turn it on, right, it's not going to go through there. So all the ground that was located around here had to go through here and through these little sections here and whatnot, until basically back to here in order to join together with the bottom ground plate. So I just added a couple of little vias there, just to give it a little bit of a path. Right, the only real current sinkage that's going to be going on in here is going to be the output from the one LED drive, from the one constant current driver right there. So you'll still get a decent amount of current going on. This will be the power LED one, right? So it's not going to be flickering on and off, but better than nothing sort of deal. And before we finish this off, let's just take a look at the 3D display for it. I don't have 3D models for all of the parts because it's not super important for me, but you can get a quick idea as to what it's going to look like from this. So here's our comparator and our passives. There's our couple of different parts necessary for the basic uncalibrated constant current sinks. There's some of the larger screw terminals at the very least, and these ones will of course be populated by the smaller screw terminals. And we just flip it over. There's just a quick look at the back. I did my best to absolutely minimize the number of traces that were on the back. I'm sure there's a way that I could have gotten gotten away with not having these ones on the back too, but I can only spend so much time on this stuff, right? And that's gonna work out just fine. Just fine and dandy. So there's the board. In a couple weeks, I will show you all the final design. We're going to also, once I build it up and everything like that, test it out in the lab just to see, you know, make sure that our light sensitivity is as required in the application, and hopefully everything works out. So if you guys like the video, give the big old thumbs up. Leave a comment down below if there's anything in particular that you'd like to see more of or want me to talk about. Be sure to let me know, you know, either in comments, hit me up on Twitter, send me an email, whatever. And be sure to check out all the stuff that I have for sale on my website. I don't suppose I've explicitly ever said that at the end of a video before, but I would appreciate it. I do try to do this all as a full-time job now that I'm done with my master's degree and everything like that. So I'd rather continue to work on open source hardware, continue to put out content for people out into the world, but I do need your support in order to continue to be able to do that. It's not like I'm making a whole bunch of money here, people. So anyways, that's it. Hope you guys enjoyed it, and I will see you all next time.